Having talked about why IPSs are important and also to some extent how intrusion prevention systems work, what I'd like to do now is talk a bit about how you might measure the efficacy of an intrusion prevention system, and in particular, talk about how you know that the IPS is doing the right sorts of things on traffic, and what are the metrics that are used to kind of measure that concept. So to begin with, let me actually draw a bit of a table here, which I think will help give maybe a bit of a visual to make things more clear. Imagine you have a bunch of traffic flows, and some of these traffic flows are going to be clean. In other words, they're not harmful at all. And other ones are going to be malicious. Maybe there's a piece of malware as a payload, or maybe somebody's trying to mount an exploit. And this is what you might actually see, on a network. Okay. Now, on the flip side, you might have, in addition to what you actually see, there's also the question of what the IPS device said about those traffic flows. Maybe the IPS classified some of these as clean as well, and might have also classified other ones as malicious. And obviously, if it's an IPS and it encounters something malicious, that's going to result in that file being, or that traffic flow being blocked. And likewise, and also an alert as well. And likewise, if the IPS classifies something as clean, that traffic flow will then be kind of allowed to go on the network. And this is also this kind of table here is what's called a confusion matrix. And the term confusion matrix is actually, it's more of a machine learning term, and I don't see it applied too much in the industry, but this term has existed for some time, so I'm going to use it since it's the proper way to talk about these concepts. Okay, and now in the confusion matrix, let's look at some of the different areas. And I think the two different boxes of this matrix that are the most relevant from an efficacy perspective are this box and this box. And so in the first case, you might have a case where the IPS labels something as clean when in fact that file is actually malicious, or in fact that payload is actually malicious. And in that case, we have what's called a false negative. Okay, and the reason it's called a negative, even though it's you're dealing with something malicious, is that when the IPS actually triggers, that's considered kind of a positive event, and it's the actual IPS is triggered. And so when it does not trigger, when it fails to trigger, if it calls something clean, that's considered a negative event. And the word false there is to say that it made an incorrect assessment that something was a negative. In other words, it calls something a negative by mistake. Okay, and why would that actually happen? Well, there's a couple of reasons why that could happen in theory. So first of all, you could have maybe a too narrow of a signature. So the signature might be too narrow. Okay, and let me give maybe a bit of an example. This is a toy example. So imagine your signature is something of the form, look for the string, you are now owned. So you are now owned. Okay, and look for the string over port 443. And if this could be your signature, and if you find traffic with these characteristics, maybe you can say with overwhelming likelihood that this file or this traffic is actually malicious. Okay, now that might be all fine and good, but what if somebody comes around and let's say this is this string happens to maybe be an encoding of some exploit for a vulnerability. Okay, now if somebody subsequently comes around and finds out that you can also exploit that same vulnerability with the string, now you are owned. Now you are owned. Okay, maybe it's possible that just by reordering some of the bytes, you can construct a vulnerability. You can construct an exploit with the same vulnerability. Then, in fact, this second string, if your IPS signature looked for this first string, then it's going to miss an attack containing this second string. Okay, so the second string will essentially cause a false negative or an FN, and that's when we talked in other videos about the notion of a vulnerability-based signature, and that would help you get around this particular weakness. But I just wanted to mention it because a lot of IPSs are very specific. Okay. The other thing that can cause an IPS to have a false negative would be a zero-day attack. So what's called an O-day or zero-day. Okay, and zero-day attacks are basically situations in which the exploit, the first seen instance of the exploit, happens in the wild. So you actually see an occurrence of the exploit in the wild before the vulnerability is well known. So before the vulnerability was public. In other words, maybe a vendor didn't even know there was a vulnerability in their systems, And the first time anybody knew about that vulnerability in public was when they actually saw an exploit for it by an attacker or a group of attackers. And obviously 0 days, because of their complexity that requires somebody to actually understand how to come up with an exploit for a vulnerability and implement that exploit and so on and so forth, you don't tend to see very many 0 days, let's say in a given year, but when they do occur, they are certainly very powerful. And then I think a third category to keep in mind in terms of efficacy is another thing that can cause a false negative is kind of timing. I mean, maybe the vulnerability was known, but there is a bit of effort and time required before you can come up with a detection capability for a new vulnerability. And if you do take some time to do that, there's a small window in which the IPS would still be vulnerable to that vulnerability, or the system would be vulnerable to that vulnerability because the IPS wouldn't have a detection capability in place. Now, obviously, IPSs do vary in terms of their sophistication and technology. There's a lot of technology in place for being able to help close that gap or help really eliminate it, to help actually capture things that aren't done purely on the basis of traditional signatures, but there's a lot more advanced capabilities out there. But I wanted to provide this example really for sake of simplicity. Okay, I'm going to stop this video right here, and I'll do a second follow-on video where I'll talk more about efficacy. Thanks a lot, and I hope you join me for that one.